This video presents our work on dynamic Gaussian-based digital twin reconstruction for articulated multi-joint objects. The goal is to reconstruct a photorealistic asset that can still be driven, edited, and rendered after its joints move. For articulated objects, visual realism in one captured state is only half the story. A useful digital twin should continue to render faithfully as joint configurations change, move coherently with its underlying structure, and remain editable as a reusable graphics asset. A static 3D GS reconstruction is fragile in this setting because it usually observes the object in too few configurations. Self-occluded geometry may be missing, and mismatches between the CAD or URDF model and the real object can assign Gaussians to the wrong moving link. Our key idea is to bind Gaussian primitives to the object's kinematic hierarchy. Dynamic multi-view sequences provide observations across joint configurations, and differentiable rendering refines both appearance and geometry while preserving which movable component each Gaussian belongs to. The URDF mesh gives us a useful prior, but it is not treated as a rigid cage. We initialize Gaussians from link-level mesh components, then allow them to adapt beyond the mesh surface so sensors, mounts, and other real-world deviations can be reconstructed while keeping motion-consistent labels. The qualitative comparison highlights why the dynamic formulation matters. In a static reconstruction, the wrist-mounted camera can detach from the end effector under unseen poses, producing an obvious motion inconsistency. Our model keeps that geometry attached to the correct link, so the rendered asset remains coherent as the arm moves. Because the reconstruction is articulated, it can be reused as an editable graphics asset rather than a fixed replay. Here the same trajectory is shown in two visual domains, the Gaussian rendered digital twin and the simulator reference, making it easier to compare motion, appearance, and downstream scene behavior. The takeaway is that dynamic Gaussian digital twins can preserve both appearance and motion. By combining multi-view observations with a structure-aware articulated Gaussian representation, the reconstructed object becomes photorealistic, kinematically consistent, and ready to be animated under new trajectories.